Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, good night. In this video, we're gonna talk about how to solve combination of transformation problem. First, we're gonna talk about the definition of combination of transformation. So, the definition is a combination of several transformation. It could be dilation, reflection, rotation, and translation. So, in a problem or in a question, for example, a point A, x, y, is reflected, so it is reflection, and then it got translated or translation, and then it is rotated or rotation. This problem is the example of combination of transformation. Do you understand? So after we understand about the definition, let's jump to the method of solving this kind of problem. So for solving this kind of problem, combination of transformation problem, we have two methods. First, we're gonna solve it separately. As it says on its name, we're gonna solve it separately, one by one. For example, I have point A, which is x, y, and then it got deleted or dilation, and then it got reflected, and then it got translated. So for the first, we're gonna delete the point A by certain scale. A, x, y. Let me turn on the light first. So first we delete the point A, delation. After that, we can get A accent, X accent, and Y accent. And then we process the A accent by reflecting it. By reflecting it. So A accent, X accent, Y accent, reflection, and then we got A double accent, X double accent, Y double accent. After that, we process this point by translating it. So we can get A double accent, X double accent, Y double accent, translation, translation. So we can get A triple accent, X triple accent, Y triple accent. This is the answer by solving it separately. Okay, let's jump to the matrix transformation. So This is the second method of solving the problem. We use the matrix transformation of each process. As we know, each process has a specific matrix. For example, reflection to the x-axis, the matrix is 1, minus 1, 0, 0. Or dilation with scale k. So the matrix will be k, 0, 0, k. Right? So we're gonna use this matrix, this kind of matrix, to solve the problem using a formula. Okay, let me remove this one first. So the formula is x-axis, y-axis, T3, T2, and T1, and then x, y. What does it mean? So x-axis and y-axis is the result. The result of the transformation. And this is the initial point. The initial point. And then what does it mean? T3, T2, and T1. T3, T2, and T1 is the matrix of transformation. So, for example, there is a question, a point A, and yes, a point A, it got reflected, and then rotated, and then delayed. So this is the first process, right? This is the second process, and then this is the third process. So T1, T2, and T3, the number is showing the arrangement in this process. So for the first process reflected, the matrix transformation is T1. And then for the second process, the matrix is T2. And then the third process is the matrix transformation is T3. And when we use this formula, don't multiply the matrix T1 times T2 times T3. So it will produce a different answer. So we times it, we multiply it by reverse the arrangement. So T3 is the first, T2 is the second, and then T1 is the last one. Okay? And it's important to notice that this formula is only if the center point is O or 0.0. So if the center point is O, 0.0, we can use this formula. But if the center point is P, A point B, we're not going to use this formula. We're going to use a different formula. So let me clear this. So there is a slightly different. If the center point is P, A, and B. Ah. A. So if the center point is P, A, B, so we're gonna subtract this one with A, and then this one with B, and then we add A, B. So if the center point is P, A, B, we are using this formula. Okay, I think it's enough for the explanation, and let's jump to the solving some problem.